So this is naming of covalent molecules. And the first thing you need to know is that covalent naming can be pretty complex, a little confusing, and the same molecule can have more than one name. So for example, O2 is dioxide, or is also more commonly referred to as oxygen gas. In fact, classes like organic chemistry, which you may or may not take in college, will do entire units just on naming organic molecules. However, lucky for you, we are sticking with pretty simple binary covalent molecules. Binary again meaning two, so molecules made out of just two elements, and in some cases even just one, like in the case of O2. So we're really just getting the very tip of the iceberg when it comes to naming covalent molecules. Just kind of keep that in the back of your head. The way you name a covalent compound, or if it's not a compound, it would be just a molecule, is exactly like type 1 ionic compounds. So go back to NaCl, LiF, the really easy ones that we did, Li2O, where you just did the name of the cation and then the name of the anion, but you changed the suffix to IDE. With one exception, this time you are going to include prefixes for the number of atoms of each type. So that's where we get O2 being dioxide. So the number prefixes are 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, and 6 is hexa. And these should not be new for anybody. And obviously there are more, but I won't give you any one that has more than 6. Obviously, as I said, these are pretty common. 4, as you might know, is tetra. If you think of the game Tetris, each of the little shapes has 4 boxes in it, and if you get 4 rows at one time, it's called getting a Tetris. That's actually where that name comes from. There is, of course, one exception, and that sometimes, especially on the first element, we don't use the prefix mono. However, if you use the prefix mono when we don't commonly use it, that's fine for right now at this level. There are some other rules that we can get into later, or you can get into later in other classes. So let's see how this works and why we need to use those number prefixes. So first we're going to take 3 compounds that you all saw in your modeling covalent molecules activity, where you were putting things together with the actual modeling pieces or figuring out the structure some other way. So we saw C2H2, C2H4, and C2H6. These are 3 completely different compounds with different properties, and so if we just named all of them carbon hydride, you wouldn't know which ones we were talking about. Compare that to ionic compounds where there's such a fixed ratio, you wouldn't have, for example, LiF, Li2F, and Li4F, or anything like that. You can only have LiF because Li is a 1+, F is a 1-, and so it must bond as LiF. So if you say lithium fluoride, you should know what chemical makeup that is. So the way you're going to name these are by naming them all carbon hydride, but then putting in numbers for the prefixes. So C2H2 becomes dicarbon dihydride, C2H4 becomes dicarbon tetrahydride, C2H6 becomes dicarbon hexahydride. These also have common names, as you saw in your packets. C2H2 is ethyne, C2H4 is ethene, and C2H6 is ethane. So you notice some similarities. They all have eth. Eth actually refers to 2 carbons. Meth refers to 1 carbon. And if you remember to ask me during class, I can actually tell you how that relates to meth, as in methamphetamines, the drug. Pro, you've heard of propane. That refers to 3 carbons. And then the ine, ene, and ane refer to the number of bonds between the carbons. So if you remember, C2H6 has a single bond between the carbons. Ane refers to a single bond. Ene refers to a double bond, and ine refers to a triple bond. So those aren't things you necessarily have to remember right now, but you can start to see some patterns. And then of course C2H2 is also referred to as acetylene. So you can see we've got all these different names. If all you remember is the very first part with the dicarbon dihydride and tetrahydride and hexahydride, you're doing fine. So let's have some examples. So CCl4. Go ahead and pause the video. And then once you've answered what CCl4 is, you can go ahead and reveal the answer. So you should have gotten carbon tetrachloride, the tetra referring to the 4 in the chlorine. This is a case where we don't use mono on the chlorine. If you said monocarbon tetrachloride, though, that's okay. I would accept that. CO2. Go ahead and pause. You should have gotten carbon dioxide. When we're talking about greenhouse gases, that's what the carbon dioxide is. H2O. As we know, its common name is water, but go ahead and pause and see if you can figure out its more possibly official name. Did you get dihydrogen monoxide? That's what you should have gotten. And then finally, N2 is dinitride, or nitrogen gas. And you may remember O2 was oxygen gas. When you have one element bonded directly to itself, that's what we usually call that gas. So Cl2 is chlorine gas, F2 is fluorine gas, O2 is oxygen gas, H2 is hydrogen gas. So that's kind of a little system for you.